Hi, good morning, everyone. I'd like to welcome you all to our World Metrology Day webinar 2022. My name is Avinash Budram, and I'll be your Masters of Ceremonies for today's proceedings. I'd like to extend a warm welcome to all in attendance this morning. Mr. Rodney Ramnard, our Acting Executive Director, Ms. Erica Caruth, the Manager of the Metrology Division, our facilitators for this morning, and officials from the Ministry of Trade Industry, and all our stakeholders present at the meeting, members of the TTBS management and staff, honored guests, and all ladies and gentlemen in attendance. So thank you everyone for attending again today. Just some quick netiquette rules as you would have seen before. Today's session will be streamed live on TTBS's YouTube page. Please respect our netiquette rules and mute all microphones during the sessions, but we will have some time, or at least if time permits, we'll have some a session for us to have some discussions with the participants. Please turn off all videos during the presentations, but again, we may ask you to turn on your cameras for a photo op for our event this morning. Right. So the theme for this year's World Metrology Day is Metrology in the Digital Era, and that will be the focus of our presentations today. That being said, the biggest part of digital transformation is changing the way we think. And with those opening words, I'd like to go straight to our Acting Director, Mr. Rodney Ramnard. He has been with TTBS for the past 15 years to do some welcome remarks. Mr. Ramnard?
Hi, good morning. Avinash, are you hearing me? Just doing a mic check.
Loud and clear.
Okay, great. Thanks, everyone. First of all, I would like to acknowledge, of course, Mr. Avinash Budram, our Master of Ceremonies, Ms. Erica Caruth, who is our manager at our Metrology Division, our facilitators for the meeting this morning, attending officials from ministries and statutory bodies, stakeholders present at this meeting, members of the TTBS management and staff of TTBS, honored guests. Good morning, everyone. On behalf of Trinidad and Tobago Bureau of Standards, also referred to as TTBS for short, I would like to welcome you to our World Metrology Day celebration. The theme for this year is Metrology in the Digital Era. World Metrology Day commemorates the signing of the Meter Convention on the 20th May 1875. The convention provides the basis for a worldwide coherent measurement system that underpins scientific discovery and innovation, industrial manufacturing, and international trade, as well as the improvement of quality of life and the protection of the global environment. The original aim of the Meter Convention, the worldwide uniformity of measurement, remains as important today as it was in 1875. TTBS is responsible for the implementation of several acts of parliament, including the Standards Act and the Metrology Act. We also function as the inquiry point for the World Trade Organization Technical Barriers to Trade Agreement. Under the Standards Act, which is Act 18 of 1997, that act governs the development, establishment, implementation, and maintenance of voluntary standards and technical regulations, which we commonly refer to as compulsory standards. And the purpose of these voluntary standards and compulsory standards is to ensure acceptable quality of products and services, assist with industrial development and efficiency, protect consumer, public, and industrial health, welfare, and safety, and protect the environment. We also, however, are responsible for the implementation of the Metrology Act, which is more in line with what we would be talking about today. And the Metrology Act, which is Act 18 of 2004, governs aspects of weights and measures to establish national units of measurement, establish national measurement standards and artifacts which are traceable to international standards, establish a metrology laboratory, and ensure that measurement devices used for trade are suitable via the implementation of several mechanisms, including legal metrology, which is used to verify measuring devices used for trade, pattern approval of measurement devices to ensure that they meet certain basic requirements for approval, and the registration and certification of persons manufacturing, assembling, importing, exporting, repairing, or adjusting prescribed measuring devices. And this last one is an area that TTBS is still working to implement. Metrology is considered a pillar in quality infrastructure, since conformity assessment activities such as inspection, testing, certification, and market surveillance often include aspects of measurement. And these activities are only as good as the measurements that support them. The theme, Metrology in the Digital Era, was chosen because the adoption of digital technology is revolutionizing the work of the metrology community. Across the globe, national metrology institutes are developing capabilities and infrastructure to action and support the digital transformation of their services. Digital transformation is the integration of digital technology into all areas of your business, fundamentally changing the way we operate and deliver value to customers. Across the world, national metrology institutes continually advance measurement science by developing and validating new measurement techniques at the necessary level of sophistication. These international metrology systems provide the required assurance and confidence that measurements are accurate, providing a sound basis for global trade today and helping us to prepare for the challenges tomorrow. The Trinidad and Tobago Bureau of Standards is currently participating in a Metrology for Digital Transformation project. The two areas of focus for TTBS in this project are automation of laboratory processes and digital calibration certificates. The application of digital measurement frameworks to industry and customers and consumers is integral to an inclusive, trusted digital transformation. The digital transformation of metrology can bring many benefits. For example, it can expedite the time required to deliver measurement products and services and reduce delays associated with the approval process. In turn, this contributes to innovation, product agility, and sustainability. The Metrology Division will be using these technological advancements from the Metrology for Digital Transformation project to digitally transform its operations through the development of a calibration management system. In closing, World Metrology Day recognizes and celebrates the contribution of all the people that work in national metrology institutes and organizations throughout the year. To the metrology staff at TTBS and all the metrology practitioners in Trinidad and Tobago, happy World Metrology Day. I thank you and wish you a fruitful session. Back over to you, Mr. Budram.
Thanks a lot, Mr. Ramnard. So before we get into our technical presentations, we have before we get into our technical sessions, we have a question and answer session at the end. So if you have any questions concerning any of the presentations, feel free to write them in the chat and we'll address them during the question and answer session. So getting right into it, our first presentation, we will have Mrs. Erica Caruth, the manager of the Metrology Division and an avid home gardener. She's also, she'll be speaking on the international perspective of metrology for digital transformation. Ms. Caruth.
Hi, good morning, everyone, and happy World Metrology Day. Are you all hearing me clearly?
Loud and clear.
Lovely. So the presentation that I'm delivering today is Metrology for Digital Transformation, the International Perspective. And the contents would include the Industrial Revolution, Industry 4.0, the role of metrology in digital transformation of the global measurement system, and Metrology for Digital Transformation, M4DT project. So going back into some history and providing some context, since the 1800s, we have experienced 3 industrial revolutions, and each was powered by a disruptive new technology. The mechanics of the steam engine, the innovation of the assembly line, and the speed of the computer. The reasons they were all called industrial revolutions was because, they would have was because the innovation that drove them didn't just improve productivity and efficiency a little bit, but it completely revolutionized how goods were produced and how work was done. We are now in the 4th industrial revolution, Industry 4.0, which revolutionizes the automation, monitoring, and analysis of supply chains through smart technologies. Industry 4.0 is powered by the Industrial Internet of Things and cyber physical systems, smart autonomous systems that use computer-based algorithms to monitor and control physical things like machinery, robots, and vehicles. Industry 4.0 makes everything in the supply chain smart, and from smart manufacturing and factories to smart warehousing and logistics. Industry 4.0 doesn't stop at the supply chain. It interconnects with back-end systems like enterprise resource planning to give companies an unprecedented level of visibility and control. And ultimately, Industry 4.0 is a major part of any organization's digital transformation. So we see a diagram here of Industry 4.2 and its connection. So in general, the general definition of Industry 4.2 is the rise of digital industrial technology. Industry 4.0 transformation allows us to work alongside machines in new and highly productive ways. This is a quote from Daniel Burrus. So what is digitalization? The term digitalization actually designates the transformation of analog quantities into discrete values of electronic storage and processing. And this term, however, is currently being used more generally to designate the conversion of the whole society to use digital technologies and increase involvement of data, machines, and business processes by means of digital interfaces. And we are seeing currently in Trinidad and Tobago where the government is embarking on digitally transforming its services, and we have a ministry called the Ministry for Digital Transformation. Okay, so moving on to the role of metrology in digital transformation. Measurement values, data, algorithms, mathematical and statistical procedures, as well as communication and security architectures represent the basis of digital expansion and transformation. Metrology for digitalization is being intensively pushed forward by means of research programs and by setting up new capacity working groups. These activities are being driven by the leading metrology institutes, or the NMIs. So for example, in the National Institute of Science and Technology, NIST, located in the US, They are actually working on a number of initiatives, fields of cloud computing, big data, IT security, machine learning, and have been building the metrological basis for the development of high performance communication channels, 5G, for a very long time. In the UK, the National Physical Laboratory has also been strongly developing the data science field as well as 5G networks and digitalization related research. And PTB Germany, I wouldn't hazard to pronounce the German word for PTB. PTB has been doing a lot of work with respect to digital transformation of metrology services, in particular the Metrology Cloud and the digital calibration certificate. Okay, so further on in terms of the role, NMIs indeed form an essential part of the national quality infrastructure and is networked with other QI stakeholders, especially for metrological services. Together, they make up the foundation for trust in products and services and are fundamental for our economic success. So the quality infrastructure, which includes standardization, metrology, accreditation, conformity assessment, testing, is now being challenged to adapt to the digital transformation of economies and society. Trusted data is a key imperative of successful and sustainable digital transformation. And through the participation in national and international committees, and by drafting data models and digital technologies, NMIs are attempting to lay the foundation for trust in metrological data. Even in a digitalized world, NMIs will continue to be committed to ensuring uniformity in metrology and traceable measurement in all processes, including artificial intelligence applications. So just to provide some context with respect to the global measurement system, World Metrology Day would have been established on May 20th, 1875 by the signing of the Meter Convention. And that provided the basis for the global measurement system. So emerging from that, there is the General Conference of Weights and Measures, which compose of the member state representatives of countries all over the world. And there is the International Committee on Weights and Measures, the CIPM, which meets annually to treat with the actual units of measurements. And we have the consultative committees, which deals with the actual measurement areas, for example, acoustics, electricity length, photometry, amount of substance, ionizing radiation, etc. So the body that coordinates all these committees and activities worldwide is the Bureau of International Weights and Measures, the BIPM. Right, so this is the foundational aspect for the global measurement system. Now, the BIPM resides in France, so this is just an image of what it looks like. Right, now, with respect to the BIPM and their digital transformation strategy, it was indicated that the aim is to develop expertise to become an anchor of trust for digital transformation in metrology, both in the services of the BIPM and through support for the work of the International Committee of Weights and Measures. Additionally, it is to support the continuous development of FAIR digital SI framework and other CIPM initiatives addressing the digital transformation of global measurements. So data that meets these requirements are what are now known as being fair. That is, they must be findable, accessible, interoperable, and reusable. And when these requirements are met, data can be recognized as being trustworthy and can underpin open data practices. So the BIPM, together with the International Organization of Legal Metrology, the International Measurement Confederation, IMECO, the International Science Council, ICS, and its Committee on Data, CODATA, signed a joint statement of intent on the digital transformation in the international scientific and quality infrastructure on 30th March 2022. Other international organizations are also expected to sign the joint statement in the future. And the joint statement provides a platform for the signatory organizations to come together to indicate their support in a way appropriate to their particular organization and to the development, implementation, and promotion of the System of International Units, SI digital framework, as part of a wider digital transformation of the international scientific and quality infrastructure. So this diagram shows the regional metrology organization, which feeds into the BIPM framework and the committees established. So there are 6 regional metrology organizations. We have CIM, which is the Inter-American Metrology System, Euromet, we have COMET, GulfMet, AfroMet, Asia Pacific. So all these regional organizations recognize each other's measurement systems, and all this resides with the BIPM, which you will hear more about further in this morning's session. Just to note that every year, the poster for World Metrology Day is designed by one of the regional metrology organizations. And this year, it was designed by COMET, which is the Euro-Asian Corporation of National Metrological Institutions. So this is a diagram of our regional metrology organization, CIM, which is divided into 5 sub-regions. We have NORAMET, which is Northern Bloc, CAMET, which is Central America, ANDIMET, which are the Andean countries, SURAMET, South America, and CARIMET, which is the Caribbean participants, which includes Guyana and Suriname. Okay, so moving on to CIM, Metrology for Digital Transformation project. So CIM developed a 3-year project, Metrology for Digital Transformation, which is being funded by the Inter-American Development Bank. And this strategy follows international best practices set out by other regional metrology organizations like Euromet, which, working through the European framework, established large cooperative projects decades ago to foster cooperation in R&D in metrology for emerging technologies, with excellent results for the NMIs involved. So the rationale for the CIM IDB M4DT project was that digital transformation processes that cross all productive sectors rely significantly on metrology and directly impact on the delivery of metrology services. Digital transformation allows NMIs to organize in new ways to provide services, and the services it provides must be transformed into new services and capabilities to adapt to the reality and needs of Industry 4.0. Responding to these needs is a problem for Latin America and the Caribbean National Metrology Institutes because of the magnitude of digital challenges they face and the limitation of resources each NMI has to face the challenges. So the key or the main objectives of the M4DT project was new metrology services developed and deployed to address emerging technology needs used by the digitalization of the economy. And some of the specific objectives are to promote a climate of innovation, competitiveness, and productivity by enhancing the delivery of advanced measurement services needed by firms for the development and adoption of digital technologies. Also to facilitate the adoption of digital technologies by NMIs of Latin America and the Caribbean to increase their efficiency and impact. And also to promote activities of virtual metrological control of equipment between NMIs, industry oriented to the development work methodologies for Industry 4.0, through the design and implementation of a regional metrology cloud. Expected outcomes are: 1, the development and deployment of new measurement expertise to address the Industry 4.0 needs, increase the number of participating NMIs that use digital technologies in their organization and services, increase the number of research and development and innovation projects in metrology related to digital technologies and Industry 4.0 in the region, and increase emphasis on addressing measurement challenges of the digital transformation regionally, and also to have a well-trained next generation of skilled scientific staff aware of current and emerging technology measurement needs of industry and society. So SIM would have convened a working group called SIM Metrology Working Group 14 M4DT to drive the activities of the Metrology for Digital Transformation project. It would have had developed different task force groups, one being for automation of laboratory processes, digitalization in legal metrology, digital calibration certificate, metrology for Industry 4.0, and agile projects. And TTBS is actively participating in task force number 1, which is automation of laboratory processes, and the digital calibration service certificate, which you will hear a lot more in this morning's session. So thank you for your active attention. And again, happy World Metrology Day to everyone.
Thank you, Ms. Karut. So we have an Industry 4.0, a new industrial revolution. So some of these smart devices and all too that we currently have and currently use, sometimes I think they're smarter than us. And you ever had that experience where you just talk about something and boom, you just see an ad for it pop up on your phone or on your computer? It's next generation stuff. So going straight to our next presentation, our next speaker is a passionate computer techie and enjoys computer headaches. Well, sorry, I mean troubleshooting. Mr. Sue Durga. Sue is the supervisor of the Calibration Services Unit and has been at TTBS for the past 32 years. So he has a wealth of experience and experience in TTBS and in calibration metrology itself. So his discussion would be on the automation of laboratory processes. So Mr. Sue Durga.
Okay, thank you, Avinash, for that introduction. So I'll be talking this morning about automation of laboratory processes. So my contents would be: what is automation of laboratory processes? Why automation of laboratory processes? Calibration services workflow processes. We will look at what happens inside our services. What are TTBS automation plans? And finally, we'll look at our participation in some regional automation projects. So what is automation of lab processes? Basically, it's the use of instrumentation to perform laboratory processes requiring minimal human input. Automation can be used anywhere from a single step of a process all the way through the entire workflow. So this is the image I see on the right-hand side here. Basically, someone would have initially lift those weights up by hand, but our process is automated where the equipment just press a button and it's able to load on the weights and carry out the calibration. That coupled with software, the readings are taken automatically. So metrologist doesn't have to sit down and write down numbers as they would have had to in the past. As technological capabilities increase, so do the opportunities for automating laboratory processes. And nowadays, automated equipment is becoming a staple part of the lab. So they're using robotics, computers, and software. So again, with this image that you see on the right-hand side there with the use of a robot, previously, and in a lot of labs still, a metrologist has to change the plugs, turn the button on the multimeter, and so on. But there are many systems now at different levels of automation where those things doesn't require the intervention of the metrologist other than the setup the equipment initially. So why automation? Well, all businesses are interested, of course, in increasing the productivity of their services to assist businesses to also improve and also to ensure that they're able to make better profits. So two of the things that need to be looked at, of course, in increasing your productivity is that you look at your system and look at the different processes within those systems and try to improve them. And by innovation and with all the different technologies that are available now, we try to build integration of those processes and to have better control over those processes to ensure that you become more efficient at what your services that you are providing. So in order to basically, when you automate, you want to basically improve your overall efficiency of your processes by speeding up tasks, reducing waste, having a higher throughput of work, and basically using lower quantities of reagents and consumables. All of this results, of course, in lower running costs of the lab. Automation also saves lab personnel from performing time-consuming
Hi everyone. We would convene in a couple minutes. The entire network would have dropped. So thank you all for holding on, and we would wait a couple minutes for everyone to rejoin and continue with the presentation.
Hi, good morning, everyone. My apologies, but we seem to have had some technical difficulties this morning. Can everyone hear me? You can just unmute and just answer?
Yes, we hear you.
Right.
Hi, good morning all. Thank you for your patience. We're still experiencing technical difficulties at this point in time. So please just give us 5 more minutes as we wait for participants to also rejoin us. Thanks a lot, everyone.
All right, so good morning again. I must apologize again and again for our technical difficulties this morning. It goes to show you shouldn't make jokes at the computer's expense because they're listening to us. But we'll continue straight along with our presentations, and we'll try to pick up from Sue's presentation. So we just give him a few minutes to get set up again, and we'll go straight into Sue's presentation.
Avinash, you're still getting connection unstable.
Okay.
But we are hearing you clearly, Sue.
Yeah, but I was just getting a message about unstable connection. But we'll try and see how it goes.
Yeah.
Can you cast it? Can you do this screen share or?
Okay, you see my screen?
Yep. So I hear you loud and clear as well.
Okay, so whenever you're ready to go, you can restart.
Okay. So for the participants, you want to just give us a little message in the chat if we can continue. Right, good. So we're getting some messages in the chat too, so feel free to continue. And for the participants as well, feel free to utilize the chat for any questions.
Should I resume just from here or start from the beginning?
You can resume from there, Sue.
Okay, again, just as Avinash said, we apologize for the break in our session. So continuing, why automation of lab processes? Because it improves the overall efficiency of processes by speeding up tasks, reducing waste, get a higher throughput of work, and you're using lower quantities of reagents or consumables. This results in lowers the running costs of the lab. It also saves lab personnel from performing time-consuming and repetitive tasks, freeing them up to carry out more specialized processes. Automation increases data reliability and accuracy, as error and variability can occur at all stages of the process. Automation improves lab safety by using automated systems that correctly handle calibration items. Consequently, lab personnel are protected from exposure to repetitive and or potentially unsafe tasks. So what the image you're seeing on the right-hand side is a robotic mass comparator for comparing weights. And it'll be pretty hard on metrologists to be able to be lifting up those 10 kg weights on and off throughout the day. So having a robotic mass comparator, again, automating that process will make it a lot easier on the metrologists. Next, we look at our calibration services workflow processes. Our process usually starts by a customer submitting a request. And there are a lot of different operations that happen within our calibration services process that the customer would not be aware of. But by improving these workflow within our system here, we can ensure that the experience that our customer gets is much better, and that they get value for their money and they are satisfied, and that their process can also be improved by extension. Our process usually ends by the customer submitting payment, but it's not the actual end because there are other interactions with the customer that can take place, which as we go along, we will discuss. So at the beginning of our process, customer submits a request, and we call that an RFSQ, which is request for calibration service or quotation, because some customers may just need a quotation, whereas others actually want their items to be calibrated by TTBS. So that's the first step in the process. The request for calibration service is an Excel spreadsheet that contains instructions and allows the client to be able to fill in the necessary information to help us to be able to cost the job for them. So that request comes in to our operations assistant, who handles the request. They review it to make sure all the relevant information is contained in it. If not, sometimes there's a back and forth with the customer. If it's a new piece of equipment or there is something that's not clear, then the operational assistant will consult with our technical staff, who will review the request and provide feedback to be able to ensure we have all the information to be able to calibrate that piece of item that the customer has. The next step in the process is the operation system will prepare a CSOC or CSOC, which is a calibration service order contract, which would also include the costing for calibration of the items. And this is sent back to the customer for their review and approval. The customer then signs the calibration service order contract and sends it back together with a purchase order. This is then reviewed by our operations assistant. And once everything is fine, the purchase order and the calibration service order contract have the right information, it's signed off. And then the operations assistant consults with the technical staff, both the officers and the technician in the lab, checks what items are already scheduled, provide a date on which the customer can submit their items for us to calibrate. So that information is emailed back to the customer with the scheduled date, as well as a scan of the signed contract. Next, the customer on the scheduled date will submit the calibration items to our operations assistant at our front desk. And there it's received and registered in our system.
Hi, good morning. Good morning, everyone. Can you hear me again?
Yeah, Avinash, we are hearing.
Okay.
Okay, so it seems that the internet problems that we're having are persisting, and it's already 11:15. So it mean we may not be able to continue with the presentations for today. So in every dark sky, there's a silver lining. So what we will do instead is that we'll close off the session for today, but we will keep you all informed, and we'll have something specially prepared for you for Will Metrology Day. So keep a lookout. What we'll try to do is to pre-record the sessions with all the presentations, and we'll post it to our social media pages. So again, my apologies for all the interruptions today, but it was really beyond our control for today. Um, any questions anybody has thus far? While we have the internet up, if anybody wants to ask me or ask any of the presenters anything. So hello again. For those of you who can hear me, we'll have to postpone our World Metrology Day celebrations for today. We'll send out an email to those participants. We should have the email participant list, and we'll let you know what the way forward will be. But most likely what we'll try to do is to have the presentations pre-recorded, and we will post it to the social TTBS social media, so you can view it at your leisure, right? So with that being said, unfortunately, we'll have to wrap up today's session.